Hello, my name is John Mayen and I am in the 10th grade. This is my honors video for my Algebra 2 class for the spring semester. So today we'll be going over linear and exponential functions. Attack of the virus, the linear and exponential truth. So what happened? In an episode of Star Trek, an alien contaminates the Enterprise with a strange virus. 10 members of the crew get the disease within 1 hour, and 1 hour later, a total of 22 crew members have been infected. So, what key information were we just given? At the start of the epidemic, 10 people were sick. And then within 1 hour, 22 people were sick. So, problem A states, assume the number of people infected with the disease each hour is growing linearly. How many people would be sick after 3 hours, after 3 days? How long would it take for the disease to infect 100 people? Dr. McCoy finally discovers an antidote, but it takes him 8 days. He only has enough serum for 2,000 people. Is it enough? Explain why. So part 1 of question A states, number of people infected is growing linearly. How many people will be sick after 3 hours? So to help us out and to help us graph the line, let's make a table. So we were given the information that at the start of the epidemic, 10 people were sick. So for X, we'll make X the hours and Y the number of people infected. So for when X is 0, Y is going to be 10 because, as stated previously, at the start of the epidemic, 10 people were sick. Then we were also giving that within 1 hour, 22 people were sick. So when X is 1, Y is going to be 22. And to find and predict the next numbers, you have to find the change in Y. So within 1 hour, 12 more people got sick because 10 plus 12 equals 22. So with that information, we were able to find the rest of the hours and how many people were sick in the future. So if we add 12 to 22, we get 34. If we add 12 to 34, we get 46, and so forth. Add 70 plus 12 and you get 82. And as you can see, the change between all of these is constant, and that shows that this is a linear function because you're adding 12 and you're not multiplying. The change isn't different throughout all of the numbers. It is a constant addition of 12. So the equation that we can make from our information is y equals 12x plus 10, where 12x represents the slope or how the numbers and what the numbers increased by. So since the number is increased by 12, that's going to be our slope, 12 over 1. The b, or the 10, equals the initial value because you were given the information that at 0 hours or at the start of the epidemic, 10 people were already sick. So to answer the question, how many people will be sick after 3 hours? Well, by using your table, we were able to say that after 3 hours, 46 people will be sick. How many people would be sick after 3 days? So to find this, we have to start plugging in numbers into our equation. Since there are 24 hours in a day and the question asks how many people will be sick in 3 days, we have to multiply 24 times 3 and we get 72 hours. So if we plug that in for our x, since x represents hours, we would get y equals 874. So after 3 days, 874 people will be sick because, as you can see in the work shown, when we plug in numbers, we get y equals 12 times 72, which means the number of hours in 3 days, plus 10. So then that equals y equals 864 plus 10. And when you add those two up, you get y equals 874. And y represents people, so that's the amount of people that will be sick after 3 days. So how long would it take for the disease to infect 100 people? Well, since y equals people, we could plug that into our equation. So 100 equals 12x plus 10. That's going to be our equation after we plug in 100 for y. So we can subtract 10 to both sides to get the variable on one side by itself, and we get 90 equals 12x. If we divide both sides by 12, we would get y equals 7.5. So it will take 7.5 hours for 100 people to get sick. Dr. McCoy finally discovers an antidote, but it takes him 8 days. He only has enough serum for 2,000 people. Is this enough? Explain why. So again, we have to kind of transform our days into hours because we can only use hours. So since there are 24 hours in a day and we're trying to find the number of hours in 8 days, we want to multiply that times 8 and we get 192 hours. So we can plug that in for our x since x equals the number of hours. So then we get y equals 12 times 192 plus 10. 12 times 192 is 2,304. So then we add that plus 10 and we get 2,314. So Dr. McCoy will not have enough serum for everyone once he discovers it, because by the time he discovers it, 2,314 people will have gotten infected and he only has enough for 2,000 people. So he would not have enough because there would be 314 people who would not have gotten serum because he only made enough for 2,000. So now moving on to exponential functions. So problem B. Now assume that the disease spreads exponentially. How many people would be sick after 3 hours? After 3 days? How long would it take for the disease to infect at least 100 people? About how many hours does Dr. McCoy have to discover an antidote if he will only have enough serum for 2,000 people? So let's break this problem down because this is a lot of information that is being asked for. Part 1 of question B states, number of people infected is growing exponentially. And it asks, how many people will be sick after 3 hours? So at the beginning of the problem, we were giving the information that at the start of the epidemic, 10 people were sick. And then within 1 hour, 22 people were sick. So if we plug that into our table, we would put x equals 0 for the start of the epidemic, equals y, and then for the y side, we would put 10 because we were told that at the start of the epidemic, which is 0 hours, 10 people were already sick. That goes the same for when x equals 1, we would put 1, and then for the y side, we would put 22 because we were told that within 1 hour, 22 people got sick. So to predict the future number of people that are going to be infected, we can find the change in y. So since this is an exponential, you have to multiply, not add, as you would in a linear function. So 22 divided by 10 is 2.2, or 10 times 2.2 equals 22. So by using that information, we are able to predict the future hours. If we multiply 22 times 2.2, we get 48.4. If we multiply 48.4 times 2.2, we get 106.5, and so forth. And as you can see, all of these stay constant and are constantly multiplied by the same multiplier or ratio. And as you can also see, since the start to within 9 hours, the number of people that are infected grows very drastically. And this indicates that it's an exponential function because in an exponential function, the change in y grows very drastically and dramatically. So the equation. For right now, the only information that we could put in is y equals 10 times b of x. And the 10 represents the initial amount of people that are sick. But we found the multiplier, so we are able to plug that in for b. So 10 is going to equal, like I said, the initial value. And b is the unknown exponential ratio multiplier. So how do we find the equation's ratio? We could plug in 22 equals 10 times b to the power of 1. And that the 1 represents the 1 hour, and the 22 represents the number of people that were sick in an hour. So by plugging that information in, we can divide both sides by 10, and we get b to the power of 1, which is just b, is equal to 2.2. And our final equation will be y equals 10 times 2.2 to the power of x. So moving on to the questions. How many people would be sick after 3 hours? Well, we can either use our table to find this information, or we can plug it into the equation. So the easier way would be to plug into your equation. So we could plug in the 3 for the x, since x represents hours. Y equals 10 times 2.2 to the power of 3. 2.2 to the power of 3 equals 10.65. And 10 times 10.65 is equal to 106.5. So after 3 hours, 106.5, approximately 107, because you can't have half a person being sick, will be sick. So how many people would be sick after 3 days? Well, we have to change our units of days into hours, so we can be persistent and constant throughout our whole problem. So since there are 24 hours in a day, and we're trying to find the number of hours in 3 days, we multiply 24 times 3 and we get 72 hours. We can plug that into our equation. Y equals 10 times 2.2 to the power of 72, because 72 is taking the place of x, and x represents hours. So 2.2 to the power of 72 is a really, really large number. It equals 4.512664216e24. And that e actually says and represents that it is a very large decimal. So large that it's going to shorten it up by using an e. So when we multiply 10 times 4.14 blah blah blah, we would get y equals 4.512664216e25. After 72 hours, 4.126642116e25 people will be sick. So how long would it take for the disease to infect at least 100 people? Since y equals and represents the number of people infected, we can plug in 100 for y. So 100 equals 10 times 2.2 to the power of x. We're trying to find time, so that's why x does not have a number to plug in, because you don't know how long it takes to infect 100 people. So if you divide both sides by 10, you get 10 equals 2.2 to the power of x. And since we don't really know the power right here, we're going to use log to help us find the power. So log of 10 is equal to log of 2.2 to the power of x. So that last part, log of 2.2 to the power of x, is also equal to x times log of 2.2, because the inverse of an exponent would be to multiply the whole thing by that exponent. So from here, we can divide both sides by log of 2.2 to get the variable x alone. You can cross out log of 2.2 divided by log of 2.2, because that equals 1. So you're left with x equals log of 10 divided by log of 2.2. And that, when you put in your calculator, is equal to x equals 2.92. So it is going to take, it's going to take 2.92 hours for 100 people, at least 100 people, to get sick. About how many hours does Dr. McCoy have to discover an antidote if he will only have enough serum for 2,000 people? Since we know the number of people, and that equals y, we can plug that in for y. So 2,000 equals 10 times 2.2 to the power of x. You can divide both sides by 10, and you're left with 200 equals 2.2 to the power of x. Again, we can use log because we don't really know how to approach the exponent, and you really can't, because it's not like you can divide both sides by 2.2, since x isn't being multiplied, it's an exponent in this case. So log of 200 is equal to log of 2.2 to the power of x. And that last part, log of 2.2 to the power of x, is also equal to x times log of 2.2, because the inverse of an exponent is to multiply everything by that exponent. So you can divide both sides by log of 2.2 to get x, the variable, alone. And log of 2.2 divided by log of 2.2 is also equal to 1. So you're left with x equals log of 200 divided by log of 2.2. And that, when put into a calculator, is equal to x equals 6.72. So Dr. McCoy has 6.72 hours until he discovers the antidote, if he only has enough for 2,000 people. Problem C, the graphs. So part of growth is graphs, and that's a visual representation of a table of numbers in action. So sketch a graph of each of the two situations above. Make hours the independent variable and the number of infected people the dependent variable. Does either graph have an asymptote? Explain how you know. So we'll start with the graph for the linear function. So at the start of the epidemic, 0 hours, 10 people were sick. And each hour, 12 more people became ill. So by using our table and the numbers, we can plot this linear function and linear graph. And the asymptote would be at 0, 0, because you can't have a negative amount of people sick or a negative amount of hours. And this is proof that our function was linear, because the line is straight and is steadily growing, instead of having a parabola, which is quadratic, or an exponential, which drastically changes and is curved. So the growth of this graph shows that the disease and epidemic grows steadily and not drastically. So now the graph for the exponentials. At the start of the epidemic, 10 people were sick. And in 9 hours, 12,072 people were sick. So as you can see here, this graph's line drastically curves up, which shows that over time, the amount of people that are sick actually starts multiplying and doubling and stuff like that. And the asymptote for this graph would be at 0, 10. So thank you for watching my video, my honors video, and I hope that you enjoyed it and learned about linear functions, exponential functions, and how they can be applied to real world problems such as epidemics.